Hello, everyone. So first of all, you may hear some banging and clanging. The neighbors behind me are building an ADU on their house, so it's not terribly loud, but it is there. Anyway, today on the bench we have an HP 34401 Alpha. You've probably heard me mention that I don't have a great bench DMM, so I intend for this to become that. I got this on eBay for $308 and 63 cents with shipping all day. And it has a bunch of error messages. So first I'll just turn it on, and that's fine. But if you run the self-test, if you hold the shift, turn it on, beeps at you, and it'll run through its self-test. Takes a second. Fail. So you can see all the errors. I had to make myself a cheat sheet on the menus, how to use this. So let's see. Shift, menu. I want system menu, reading store, error. There we go. So 612, 613, 615, 617, 618, 619, and 621, and back to 612. So what is that? 7 errors. So we'll take a look at the manual real quick, and I'll show you what those errors are. Before I purchased the unit, I did a search on those error codes and got a lot of hits. eevblog has this thread here, same exact error codes, all 7, right? So, you start to scroll down, very smart people in here as usual, and a lot of pointing to U201. So, replaced, solved. A year ago I had the same problem, U201, replaced and good to go. So, felt pretty good that this is probably the same issue mine's having. This is U201, by the way. It's a op amp, 2-circuit. It is surface mount. It's only about $9, and here's the data sheet. So, I did order this, and it came in, and I started to troubleshoot. Before I swapped it out, I started to troubleshoot around it. Here's U201 on the schematic, both halves. You get your A half and your B half. I checked the voltage reference, supposed to be 7 volts DC, and it was dead on, 6.98, so that was nice. This is supposed to be 18 volts, and I was only getting 8.84, so that seemed odd and not correct. So I walked it back, and you walk it back to another sheet. This is basically the input transformer on this side. And here's our 8.83, supposed to be minus 18. I started by checking all the resistors around this. They were all really good. 239, 316, these were like bang on. This one may be a little low, but pretty much on. There's also some big caps here. So there's 2 here. There's one more on the lower half of this. But out of the transformer, we got about 44 volts VAC. Then out of the rectifier, 54 volts VDC. I'm supposed to have 26 here. Well, you figure 54 divided by 2 is roughly 26. So you got your plus 26 and your minus 26 here. And then on the bottom half of this, same kind of thing. Another winding here, 9.3 volts AC out of the transformer. I had about 10.6 out of the rectifier. Here's that third big cap, 2200 micro. And yeah, 5 volts DC for VCC. I also checked here. I had 5.01, supposed to be 5. So this all seemed good, but these caps I still wanted to check. So I checked those caps in circuit. So we've got the 3 on the top here, C551, 553, and 556. 2 1000 micro and 1 2200 micro. In circuit, the ESR was very high, over half an ohm. So I pulled them out of the circuit and checked them again. A little lower on the Atlas, 0.33, 0.42. My Model 253 measured a little higher there. So they didn't agree exactly, but kind of backs me up that these were too high. So I bought new ones, Nichicons, and sure enough, out of circuit, dead on, right? Way low, as they should be, 0.03, 0.02, 0.06. So I did go ahead and replace those 3 caps. Always a good thing to do. Likely the originals in there, quite old, and not a bad idea to refresh on those electrolytic caps. So before I even changed those caps, I came back and turned it on. I was going to do some more checking, and this 8.84 had become 18.89. I had not even changed anything. I don't know what happened. Maybe U201 finally gave up and became an open there. Maybe the 8.84 was it, consuming that voltage, dragging down the rail. I don't know, but it was 18.84 or 18.89, so that made me feel pretty good about the input here. I figured U552 and U551 are probably okay. So anyway, still changed the caps, and yeah, then I went ahead and changed U201 itself. So this is the chip we got to replace, and I'm going to use this iron, which is probably not ideal, but I don't have all the fancy stuff, hot air and all that. So we're gonna try this. I am gonna tape up the surrounding area first. Try to keep the heat away from it. I think what I'm gonna do is use solder wick and just try to pull up as much of that solder on these 8 pins as I can, and then hopefully with some tweezers I can lift it up gently. Lift it up. I think my strategy of removing solder with a wick is not going to work. I think I need to go the other way, actually, and add solder so I can get all 4 at once and then pry it up with a scribe. So I'm going to try that. There's another gentleman, I'll link his video below. He did that, and it worked pretty well. So we'll go that route. So I kind of gobbed it on the one side there. I can do this with my offhand. So one side's lifted. Now we'll try it with the other. And the tweezers. Gob some solder on here. Or we'll just pop it out like that. Okay. There she is. I've got all 8 legs, so that's good. How much damage did I do here? Let's get some wick in there. You can see the big old globs of solder there. Ooh, damn it, I did move a pad. Son of a bitch. So that top right pad has been shifted over. Don't like that. Let's see if I can. Slide her back. Ah, there we go. Just slid it back just a bit. Whew. Okay. Okay, she's set on the pads. And kind of just sitting right on top. I'm going to do my best here. I'm going to do this with 3 hands. So I'm going to hold it down with the tweezers, just a little pressure on top, and just try to tack on 1 pin. Okay, there's 1. It's not pretty, but I think I got it. Let's get this out of here. Yep, 1 through 4 look pretty good. Excuse me, 5 through 8 look pretty good. I think that's going to do it. At least, well, we'll turn it on. We'll give it a test. She's all back together. I've got my 3 caps that I changed here and a tiny little chip there. Let's do a self-test. There's that pass. I did check it on a bench power supply, and it was about 3/100ths of a volt off what the supply said, so I'm good with that. We'll try some resistance measurements here, just 2-wire, just for fun. So I've got a decade box here. We'll go 100 ohms. Excuse me, 900. 900 ohms. So 0.9 kilo ohms. Let's try 1 meg, 0.997. Try 5 meg, 4.99. We'll try 9K. There's 9K, 8.98. And back to 0. Yeah, about an ohm in my cables. So anyway, pretty good. I'm stoked, man. $8 chip, a few bucks in caps. Big shout out to eevblog. I would not have even known where to start, but it's nice when people share their knowledge, because a lot of people had the same problem, and that's why I bought this. And sure enough, that chip did the trick. So I am not sure if I'm going to get it calibrated professionally or not. There's a service that's not too far away in Medford, Oregon, but the base is $175, which is quite a bit, plus shipping, and I think that's calibrating without data. I don't know that I need the data, but to me it's like, well, if you're already calibrating, why not just hit print and provide the data? That's more. I don't know. Maybe there's a reason for that. I'm sure someone in the calibration industry can tell me. But in any case, I'm very stoked. I got to find a spot for this on my bench. I was thinking either on top of this or this on top of that, but boy, this thing is deep. It goes way back. It's like 13, 14 inches deep. So I got to get a right angle plug to start and then maybe rearrange some stuff on the bench. But in any case, it's working, and I am stoked that I have it. So what a good pickup and a good fix. So thanks for watching. Please like and subscribe. That'd be awesome. And I'll see you in the next one.